Hello, my young Padawans. I'm glad that you're here. Well, not here, but here on the internet. I need you to work hard. Even though we're not together, you still have a job to do, and that is to increase your knowledge. While we're away, this is going to be challenging, but I need you to work hard just as if you were here. Take good notes as I go through the lesson, and of course, email me if you have any questions. I will always be there to help. I can trust that you're going to do a good job because you are stellar. We don't know how long this is going to last, but you need to work hard for yourself. I know that you will. So, get your things ready. Here we go. Oh, I'm going to wear a hat because we got lights. I balled the glare. You get it. Here we go. Are your notes ready to go? We've got lesson 111, solving problems involving permutations. Big word. We'll talk about what that is. First, see if you can get this. A wuzzle. The good news about videos is that you can pause if I go too fast. This is forefathers. Here's another one. Easier, sideburns. Okay, here we go. We're going to talk about something called the fundamental counting principle, which is all this information here. But it's very easy and you actually already know what it is. Take a look here. A restaurant offers 4 entrees and 5 vegetable dishes. How many meals with 1 entree and 1 vegetable dish can you purchase? And the answer, of course, is 20. You just take how many possibilities of each there are and multiply them together. Here's another example. With 5 hats and 3 pairs of sunglasses, how many combinations are possible? And the answer is, you got it, 15. 5 times 3. Okay, this is some brand new notation that you have never seen before. It's called factorial, and it is notated by an exclamation point. Here's what this means. Let's see 7 factorial. It means 7 times 6 times 5 times 4 all the way down to 1. I'm going to show you how to do this in the calculator. So bring out your calc and I'll show you how to do this. Okay, go to the math button, which is right over here. Math. Hit it. And we're going to be living in the world of probability right there. So scroll over to probability. And you're going to see choice number 4 is factorial, the exclamation point. So if you choose it now, you're going to be in trouble because you didn't put in the value. So what we have to do is clear everything out and then hit 7 factorial. So go back in, math, probability. And you want choice number 4. So you can see here 7 factorial. Hit enter. That's the answer because it's 7 times 6 times 5 all the way down times 2 times 1. Okay, now that you know what that is, take a look at this. How would you calculate 9 factorial divided by 4 factorial? This is what 9 factorial is. that's 4 factorial. But take a look at what cancels. 4, 3, 2, 1 cancel, and so the result is not 5 factorial, but rather it is 9 times 8 all the way down to there. Go to the calculator, plug it in. Probability factorial divided by 4 factorial and there's the answer, 9 times 8 times 7 times 6 times 5. Okay, there we go. This is where we're going to live for the rest of the last lesson, is permutations. So here's the formula for permutations right there. But we're not going to spend a whole lot of time looking at the formula because we're going to use the calc to help us through. But this is the thing that's important here. In the world of permutations, order matters. And here's an example of why order matters with permutations. Let's say that there's 3 people running a race. Well, obviously, the order in which the runners finish is going to make a difference. So, if A comes in first place, that's of course different than if B came in first place and A came in second place. That's called a permutation. So this option there is different as well. So order matters in the world of permutation. Your school is running a recycling campaign in which 6 classes are competing to see who can collect the most recyclable materials. In how many ways can the classes finished in 1st through 6th place? Okay, I'm going to bring your attention to the formula up here. The N right there, I don't know if you can see that very well in the video, but it's the letter N. That represents how many classes there are. So it's going to be N. And then the capital P is for permutations. And then the other value right there is the R, and that stands for how many classes are we going to be counting in the competition. Well, we're going to be counting all 6 of the classes, so that's going to be the number 6. So it looks like this. And then apply this to the formula up here. It's going to be n factorial, so 6 factorial, divided by n minus r factorial, or the quantity of n minus r factorial. And that's going to be the answer. Just so you know, you may be thinking, wait a minute, isn't this going to be 0? Yes, but take a wild guess at what 0 factorial is equal to. It's equal to 1. Okay, now I'm going to show you how to use the calculator to find all this. So, get your calculator handy. Here we go. Hit the math button. Go to probability. Look at option numero dos. NPR. Now, if you hit it, this is how it's going to pop up. If you have a TI-83, yours is going to be slightly different, which I'll help you with in just a second. So, the first value is how many options are possible, how many classes are there, how many people are running in the race, etc. The other value on the other side, so hit your over arrow, is how many of those possibilities are we wanting to include in the permutation calculation. Hit enter. So there's 720 different ways that these classes can finish from first through sixth place, which is a lot, probably more than you probably think if there's just 6 competitors. So the solution here is 720. Now you may be tempted to say 720 combinations. That's incorrect because the permutation order matters. Okay, let's continue. A total of 6 classes are competing to see who can collect the most recyclable materials. In how many ways can the classes finish first and second place? So that's different. There are 6 classes. However, we're only going to be determining how many ways the top 2 classes can finish. So, if I were to give you class A and then class B in first and second place, that's different than if class B came in first and then class C came in second, or if class B came in first and class A came in second. All of those are different ways that the outcomes can happen. So go to your calculator. Let's figure it out. Now, if you have a TI-83, you're going to have to put in your N value first. So you're going to have to say 6, and then go to math, and select your permutation, and then put in your R at the end. But for those of us that have a TI-84 or a TI-Inspire, any of those, we're just going to do it the way I showed you before. So math, probability, number 2. There are 6 classes, but we're just determining how many permutations of the top 2 finishers there can be. Hit enter, and there we go. So there's A and then B, or then there's B then A. There's A then C, or C then A. You can see why there's so many of these outcomes. So the answer to here is 30. In how many different ways can the classes finish first and second of all 6 classes competing? Okay, I'm going to let you try this one on your own. So I'll give you 20 seconds to work through this on your own. The 15 members of a softball team have uniform numbers 1 through 15. They are introduced randomly at a pep rally. What is the probability the first 4 players introduced will have a uniform numbers 1, 2, 3, and 4 in that order? Give it a try. Okay, so on your calc, you should have said, get your permutation up there. Okay, the struggle is real. Math, probability, permutation, there it is. Okay. There are 15 players, but we're seeing about only 4. So, hit enter. 32,760. But, is that the answer? Let's go back to the question and take a look. What is the probability that the first 4 players introduced will have the numbers 1, 2, 3, and 4? Here's the key. You know full well that probability has to be answered in the form of a fraction. So the answer is 1 over, take a look at our number, 32,000 760 different possibilities. That's the probability that the players will be randomly introduced. Number 1 first, 2, 3, and then 4. So not very likely. You guys did an awesome job. This is going to be your practice. So open your book, take a look, and I will put the questions up here if you don't have a book. Okay, here it is for you just in case. Work hard. Love you. Email me if you have questions.